now. We are a pretty large group tonight, and I expect that there'll be a few more of us as the evening goes on. So we are also going to ask everyone to just stay on mute if you're not speaking, please. That will help with the sound quality for everyone. If you find that your internet connection is a little unstable, which given this evening's weather may very well happen, I'm going to post the call-in, the dial-in information in the chat now. So if you lose us on your audio feed, you can call in that way. How's the volume? Are you able to hear me pretty well? Okay. So for our format, a note on format tonight, we have 4 panelists: Sherry Abbott, Chris Carrick, Phil Hoffmeyer, and Christy Anderson, and they'll each speak for about 10 minutes this evening. Following that, we'll open things up for a question and answer period. You are welcome to enter questions into the chat throughout the evening's presentations if you're worried that you might not remember your questions. And if your question is for a specific panelist, we would appreciate it if you can specify that in your question. So tonight's session, as I mentioned, is the first in a series of 4 planned events hosted by Cazenovia Preservation Foundation, CACTA, Cazenovia Area Community Development Association, United Climate Action Network, and the Cazenovia Chamber of Commerce. As many of you are likely aware, the Cazenovia Preservation Foundation's mission is to protect the historic agricultural and natural resources in and around Cazenovia for the benefit of the community. As such, CPF has a long history of involvement in landscape and comprehensive planning in our community. As we saw growing interest and activity with regard to commercial solar development in our area and began to have conversations both within our organization and with others in the community, we recognized that even sometimes within a fairly like-minded group of individuals, there's a pretty broad range of opinions about renewable energy generation and both with regard to wind and to solar. And as we reached out to our partner organizations and discussed the topic a little bit further, we identified some common knowledge gaps about aspects of commercial solar projects that we felt were limiting our ability to formulate well-informed opinions on the topic. So as a result, CPF, CACTA, UCAN, and the Chamber worked to collectively organize this panel discussion series, Beyond Rooftop Solar, as an opportunity for education and community forum. And so for this first session, the goal is to provide a broad framework and build a common base of knowledge within our local community about this very complicated topic, so that we can continue to engage in meaningful discussion about how we want to see renewable energy generation implemented in our area. So we hope you find this evening's program engaging and informative. And with that, I will introduce our first panelist this evening, Sherry Abbott. She's a professor of geography and the environment and a director of environment, sustainability, and policy at the Maxwell School at Syracuse University. She's also a board member of the New York State Energy Research and Development Authority, otherwise known as NYSERDA, and a resident of our Cazenovia community here. So Sherry, thank you very much for being with us tonight.
So I've just lost my slideshow, which I sent to you. So I'm so apologize for this. Let me see if I can get back on it. Oh, shoot.
Well, we give Sherry a moment. Maybe we can let, if people haven't had a chance, if you were joining us a little bit later, we did post some questions in the chat, some warm-up questions. What do you most want to learn about commercial solar projects in general? Or what topic is most important to you when considering commercial solar projects in our area? So while we're getting slides queued up, if you would like to answer either of those questions in the chat, that would be wonderful. And Sherry, you can let me know if you would like to change things up a little bit with regard to the order.
I'm sorry. I really apologize for this after a whole semester of teaching, you'd think that I could get this straight.
We had it up before everyone was on the call.
I know. I don't know where it went. Oh, shoot. I'm so sorry. It should come up. Do you see it?
I'm not seeing a shared screen right now.
Oh, shoot. Well, let me just while I'm trying to figure this out, let me just
Why don't we, oh, there we go. You are up.
all right, sorry about that. Okay, so what I was asked to do was to provide you, often we lose sight of the fact of what the big picture is, what the 40,000 foot problem of climate change and energy use and how they're connected, and how solar and the shift towards renewables fits into this. And so I want to really quickly, hopefully quickly, now that I've lost some time in my technology here, give you a brief overview from the perspective of what we know and what we're worried about, and how does an energy transition and our interest in reducing emissions from fossil fuel burning and shifting towards renewables is really in our interest on a global basis. And then how does that translate down to the individual level? Because this is a collective action problem on a global basis, but individuals matter and individual communities matter. And the way that we work together to try to change the trajectory is going to be really important in the long run. And so at the 40,000 foot level, which is where we are pretty much in the atmosphere where we want to understand what's going on, just remember that if we didn't have this this layer of greenhouse gases in the atmosphere about 10 miles out, 5 to 7 miles out actually, then the Earth would be a lot colder. And the reason that it's getting warmer is because we keep adding more carbon dioxide, methane, water vapor into the atmosphere, and the radiation which wants to get out is getting trapped in, and the Earth has to heat up. And so the only solution to this is to try to change the amount of gases that we put into the atmosphere. So we think of this as a negative thing, but in fact, in the normal system, greenhouse gases are a positive thing. So the first question the scientific community had to answer is, in fact, are these greenhouse gases in the atmosphere increasing, and why, and what's the impact? And we know that they're increasing, and especially carbon dioxide, because it's been measured since the beginning of the Industrial Revolution. We've increased the amount of carbon dioxide by about 40%. This is the famous Keeling curve, the canonical Keeling curve, started back in the 1950s. He took some measurements in Mauna Loa, Hawaii, and showed that the concentration of carbon dioxide in the atmosphere has actually increased quite substantially over time. This is known, it's observed, it's irrefutable. The second question is, what's happening as a result of this increase. And one of the things that we have observed is as global temperature has increased, global average sea level has increased, and in the Northern Hemisphere, snow cover has declined. We're getting more of our precipitation in the form of rain, which we're about to find out. So observations, we know this from the scientific community. What's responsible? What also has been observed and measured is that, in fact, carbon dioxide emissions have been increasing because of the burning of fossil fuels, because of forest practices, changing forests into agricultural lands, and releasing methane and carbon dioxide as a result. And so this nice little graph shows that, in fact, since the Industrial Revolution, the carbon emissions have increased in the atmosphere as well. What do we know from the science? There are two pieces of this that are really, really important, that the scientific community on a global basis has gotten together to look at this question since the late 1980s. the Intergovernmental Panel on Climate Change. This is a picture of a meeting of the IPCC. Interesting factoid is that the countries assemble themselves in alphabetical order, so that most of the developing countries actually sit at the front. The US and the United Kingdom are in the back. That's why we're such good friends, because we talk to each other a lot during these meetings. This is a confab of scientific members of the scientific community. About thousands and thousands of scientists contribute, and also there's a connection with the policy community. That the end product, one of the end products of this deliberation of accumulating all of the scientific information around the world, is that the scientists discuss the results with the policy community, and they lay out a summary for policymakers, so that the science is translated into language that all policymakers should be able to understand. And one of the things that the IPCC does is look at what do we know about climate science, about the physical system, the impacts, how vulnerable are communities, how vulnerable are people, ecosystems, what do we need to do to adapt? And then also looking at the options for reducing the severity of the impacts, that is, reducing the emissions of greenhouse gases. That's what is known as mitigation. The consensus of this scientific community around the world, 195 countries, thousands of scientists, is that climate is changing, temperature is on the rise, and human activities are the cause of the increase. The other part of this infrastructure that's really key is that of the UN Framework Convention on Climate Change. This is an international treaty developed during the Rio conference in the early 90s. So it has an emphasis on environment and development, that is sustainable development. And the idea that since we've used energy to grow our economies, and developing countries still need to grow their economies, that somehow the developing countries we need to help them do this in a more sustainable way. The UN Framework Convention on Climate Change was organized to try to reach a consensus about how to prevent dangerous human interference with the climate system. The Conference of Parties meets every couple of years, and there have been various key events like Kyoto and the Paris Agreement that are coming out of this. It is the atmosphere doesn't care who put up the emissions. Every molecule is the same from its perspective, but countries do care, and they care who's responsible. Most of the developed countries feel as if they know that they're responsible, but in fact, how do we find some equitable solution to a way forward? And so there's a really strong interaction between these communities, the scientific community and the policy community, and trying to figure out where we're headed. What do we know? What do we know from the science is that as we increase the amount of carbon dioxide and other greenhouse gases in the atmosphere, the risks of temperature increases and the risk to the humans and to the ecosystems increase. And so as you look at this, is the famous burning embers diagram, things get pretty hot and things get pretty ugly as we go farther and farther along the temperature range. These temperatures are connected with a certain level of greenhouse gases in the atmosphere. And so food and weather and ecosystems and extreme events all get increasingly worse beyond 2 degrees C, that is 2 degrees C above industrial levels during the Industrial Revolution. So 2 degrees C is about 3.6 degrees Fahrenheit. And we know now that in fact, we really want to try to achieve a 1.5 degrees C, no more than a 1.5 degrees C increase. And so it looks pretty bad when we get farther and farther to the right on this diagram. The changes that occur are related entirely to what we do in our energy system and trying to solve the amount of greenhouse gases put into the atmosphere. So some of it is already baked in. that the emissions that we put in 15, 20 years ago are still in the atmosphere, particularly carbon dioxide, which stays up a long time. Methane, not so long, but it's a very powerful greenhouse gas. The more mitigation we do, the lower the temperature that we'll achieve. And that means that the harder it's a harder on the economy, harder on turning the energy system around. But the more we do, the better off we are. We're headed toward a 4°C world if we don't do things pretty quickly. We have a budget, just like every community, every household. We have a carbon budget. If you think about a 1.5°C related to the amount of emissions that go up into the atmosphere, the US, the EU, China, and India are responsible for the lion's share. The rest of the world has very little left. And in fact, we only have about 8% of the carbon budget left to get to a 1.5°C world by 2020, but around after 2020. So about 10 more years we've exhausted our budget. So we have to do this fast. And what do we have to do? We have to change how we use energy. So on the left-hand side of this diagram, this is a typical Sankey diagram. This is how the energy that we use, where it comes from. On the right-hand side is what we use it for. So one of the things that's interesting in this diagram, if you looked at this in the past, this number from coal would be higher. We've actually shifted to natural gas, but still a fossil fuel. We use a lot of this energy for generating electricity to be used by residential houses, by commercial, by industrial, and a lot for transportation, coming mostly from petroleum. So if you look at this, you say, oh, well, the answer is we should put make every car an EV, and then we should power them by electricity generated by renewables. That would be a great thing. But making that transition from natural gas to upping the ante of the amount of solar, nuclear, hydro, and wind, and we're on the decline in nuclear. So we have to do more in solar, hydro, and wind, and geothermal. And making that transition is technologically feasible, but hard to do since we've invested so heavily into the fossil system. There's a lot of rejected energy. We don't do energy transitions very, very efficiently. So there's a lot of energy that's kind of lost as heat. And the answer here is, how do we generate electricity? Do we do it? Can we make the shift from fossil fuels to solar and other renewables? And so the latest energy projections from the Energy Information Administration says that we got to go from about 11% now in terms of renewables to a really, really high percentage of renewables beyond, and to get us to net zero emissions, we've got to put in a lot of solar, a lot of wind, a lot of geothermal, and a lot of hydroelectric, and we have to shift towards an energy mix that is really heavily into the renewables. The choice of getting there is ours. This is two worlds in which we can project into the future. One that is very hot, and one where it's very, very wet in some places and very, very dry in others. But the choice of which world we get to is our own. As I said, this is a collective action problem. Turning over the energy system is a heavy lift. Even if we don't fully believe in the climate change agenda, doing energy and making the transition is the right thing to do for human health and for ecosystems. We know this from the burning of fossil fuels. Also, we have a lot of asthma and other health effects. We have very ambitious goals for reducing our greenhouse gas emissions. New York State is leading by example. Chris and others will go into this a little bit more. But the difference is that we are focusing on underserved communities like never before, those that are most vulnerable. And so that's a good thing. And the final thing is climate change is a threat to sustainability. So these solutions have to be set in the context of sustainability. We have to think about the systems. We have to think about the unintended consequences of the things that we do. So in terms of solar, thinking about life cycle analyses, trying to figure out, what do we do? What are the materials we need? What are we going to do to decommission these things? Where are they going to be sited? How are we going to assure that ecosystems are protected and the humans are protected and our values are protected? So materials in, materials out matter. So the choices are ours. And the future is ours to make. And so it's up to us as individuals and as communities to ensure that we actually achieve these ambitious global goals. So thank you.
Jen, you're on mute.
Thank you, Jack. Thank you so much, Sherry, for kind of setting up that global picture for us and building that understanding. I was on mute because it's getting very loud with the thunder at my house. So in the background there.
It is here
hope
too.
You can still hear. Next up, I'd like to introduce Chris Carrick. Chris is the Program Manager for Energy Management at the Central New York Regional Planning and Development Board. Thank you so much for being here with us tonight, Chris.
Thanks, Jen.
And Sherry, we'll have you stop your screen share, Sherry, and we'll let Chris get his slides up.
For what it's worth, the sun is shining here now in Syracuse, so hopefully that means good things for all of you in CAS. Okay, are you able to see my screen?
We are, thank you.
Okay, great. Well, thank you to all of the hosts for inviting me, and thank you to all of you for attending. I'm pleased to be part of this very august panel. Just a quick word about the Regional Planning Development Board for those who may not be familiar. Our agency was established in 1966 by the 5 counties of Central New York, shown here in yellow. We have a number of different programs in addition to energy management. We have environmental management, concentrating on water resources, economic development, comprehensive planning, transportation planning. We're one of 9 regional planning organizations across the state, covering most of the counties in the state, but not all. And we, in the energy program, organize our work across 3 main areas. One is what you might call traditional energy planning work. We work with municipalities primarily to develop comprehensive plans, climate action plans, sustainability plans, greenhouse gas inventories. We did assist the town and village with their joint climate action plan a number of years ago. We work on project development as well. It's an important aspect of our work, and I'll talk about that in a moment. We do a lot of public education and outreach through initiatives like our Solarize campaign, some of you may be familiar with. We're right now running a campaign we call Heat Smart CNY, which is aimed to replace fossil fuels that we use to heat and cool our buildings, which is another main part of the energy transition that Sherry was talking about. So just a little more detail in these 3 areas. I've highlighted in red some of the different initiatives that touch on the topic of solar. So in the arena of planning, we've worked with a number of communities to help them adopt the state's unified solar permit. We are actively engaged now and have been for a number of years, helping municipalities like the town of CAS in their moratorium process to develop solar zoning laws. On the project development side, we are managing a portfolio of community solar and other types of solar projects located on municipal land. We are working with the village of CAS to create a solar project at the water plant currently. And then on the public engagement side, again, our Solarize campaign is an example of our work in that area that touches on solar. So just some images from our various different Solarize campaigns. We're proud to say that we helped to organize the first Solarize campaign in Madison County in partnership with the county. We then worked in Syracuse and then across the whole 5-county region to help about 350 people install mostly rooftop residential solar, about 3 megawatts altogether, which at the time when we suspended or concluded our Solarize CNY campaign represented about a third of all the rooftop residential solar projects throughout the region. So that was a very instructive effort for us. We learned a lot about the technology, but also about what it takes to motivate and educate community residents to take that step. I mentioned the unified solar permit. This is a combined building and electrical permit that makes it easier for both municipalities and for solar installers to proceed with smaller projects, typically under 25 kilowatts, mostly rooftop. You can see both the town and the village have adopted the unified solar permit along with 81 other communities out of 150 in the central New York region. And then on the project development side, we had worked with a number of municipalities like the town of DeWitt, village of Skaneateles to install solar projects on their municipal facilities on a case-by-case basis, but we thought it would be helpful to aggregate the interest and the energy of municipalities together to help them to develop their solar resources in a combined way. So through our regional sustainability plan funded by NYSERDA's Cleaner, Greener Communities program, we did some feasibility work, some very preliminary feasibility work, mostly desktop analysis to identify build-ready sites. And we identified a number of projects, about 83 megawatts worth altogether. But that really set the stage for our Solarize municipal solar campaign that we're currently engaged in. You can see here a number of the projects that are moving towards construction or are in current construction currently. Many of these are landfill projects, like the town of Skaneateles project here on their transfer station. That's a 1 megawatt project. Town of Elbridge, about a 3.5 megawatt project. A project at the Cayuga County Jail facility. That's actually a 5 megawatt project. The City of Auburn landfill. That's a 7 megawatt project. You can see here in the lower right-hand corner is the Village of Cazenovia project, which is a smaller project in our portfolio, but will cover 100% of the village's electricity and provide about a 5% energy cost savings for the village moving forward. Now, our approach was to try to direct development towards these brownfield sites or underutilized sites in an effort to preserve green space, open space, and prime farmland. Certainly, we're seeing the majority of development activity oriented towards those types of greenfield sites. And as I think folks in the Cazenovia area know, that those can be controversial sometimes because of the impact on farmland and view sheds particularly. And so that's part of the motivation for why we have organized our project in the way we have. Sherry mentioned the state's leadership. Really, New York and California, Massachusetts are probably the leading states across the country in this area. Many of you are probably familiar with the Climate Leadership and Community Protection Act passed in 2019, which has established nation-leading goals in the area of greenhouse gas emissions reductions, but also in terms of moving our electricity system towards clean, renewable energy sources, zero carbon sources. So 70% of our energy is targeted to be renewable energy by 2030, just a short 9 years from now. And some specific targets were laid out as well. So 9,000 megawatts or 9 gigawatts of offshore wind by 2035, 6,000
Chris, you froze.
Everyone was frozen for a minute, but let's give it a second. We'll see if we get Chris back. Oh, so much for the weather being better in Syracuse. Let's see. We'll see if he tries to join us again. Let's give him just a minute. We'll see if he can pick up where he left off. And if not, we'll move on to the next speaker. Okay. I don't see Chris trying to join us again right at the moment. So we'll, if you don't mind, we'll mix up the order of events here a little bit, and we'll hope Chris will be able to join us back in a moment and finish up. And in the meantime, we'll put our next speaker, Phil Hoffmeyer, on the spot. He probably thought he had a couple more minutes. So welcome, Phil. Phil is the Associate Professor and Chair of the Environmental and Renewable Resources Division at SUNY Morrisville. He's also currently serving in the role of Interim Assistant Dean of the School of Agriculture, Business, and Technology. So welcome, Phil. We'll have you start in now, if you don't mind. Thank you so much.
Certainly. And like others, I'll just make sure we can all see my screen. Is that true?
Yes, it is. Thank you.
Perfect. Okay. So what I wanted to talk a little bit about is dealing with a lot of the questions that I get from both my students as well as communities that I've worked with quite a bit, increasingly from wind in the past 6 or 7 years, moving toward larger solar for the last couple of years. And some of these questions I think I've heard from this group as well. And so I'm hoping that we'll be able to tackle kind of going from the large, really big global scale down to what Chris was talking about, which is the kind of the local community scale, and getting into the nitty gritty that a lot of individuals are concerned about, which is how do we know if solar works in our community, and how do we actually pick where those things happen to be located? And so some of the guiding questions that I'm interested in that I think might represent some of your questions are, it's cloudy and raining right now. So do solar panels even work in upstate New York? And if they do, what do we get out of it? How much is produced? How much space do we physically need? And how do we kind of pick these locations, and how do we avoid sensitive areas? And my goal in doing this is that if we can understand the process, then we can make siting and planning a very intentional kind of practice at the community level. And so that siting is going to be pretty critical for us. And then the other questions I get are they safe? How long do they last? What happens when we're done with solar systems? And so I'm kind of break this into 2 hunks. And the first hunk I'm going to do from a developer's standpoint, not from a community standpoint. And the reason I want to do this is I want to show you what a developer would do with an area so that a community understands what a developer is looking for, and then we can respond to it, hopefully in a proactive sense. And that's much easier than doing it in a reactive sense, which is what I see a lot of communities kind of by necessity doing right now. So if I'm a developer, and if you've driven past any of the large solar projects going in central New York, you have probably seen the work of one of my graduates, whether it's doing the actual installation work or the development side of things. And so what we always do is start with requirements. Okay, what are the legal compliance of putting a solar project in, and who are the landowners? And this is true for both participating and non-participating members. And what does that mean? It means if I want to put solar panels in this area, those who I'm going to lease the land, they are a participating member. Those who are not actively in a lease agreement of any type, they are non-participating members. However, there is community impact for both participating and non-participating. So we have to be aware of both of those groups. And in terms of legal compliance, I just pulled one example. So this comes from the relatively new 94C section of the executive law. And this has to do with planning development. And so they have some siting requirements that have been set up by the Office of Renewable Energy Siting. So for instance, if you have a non-participating member, you have to be at least 100 feet from a property line, 50 feet from the center line of a public road, 250 feet from occupied residences that are non-participating. And I'm just using this as an example, okay? There are lots and lots of requirements and setbacks and legal things that have to be reviewed. But I'm going to start with some of those. Then the next thing I'm going to do is do a little quick Google searching. And as a developer, I'm going to look for open lands, whether that is big parking lots, okay? Sometimes that will work. Brownfields are great. Farms. Those are the 3 easiest access sites. And then cross-reference that with 3-phase transmission lines. So if I have those 2 things available, open land and a transmission corridor, then I'm going to ping that landowner and say, hey, would you like to put solar on your property? And so this is what I've done. And since we're focused on the greater Cazenovia area, this is in Fenner. So this is the Fenner Renewable Energy Education Center. And I picked this for one reason really, and that's that any one of us can drive up to this site and look at what I'm about to show you. So you have a reference, a frame of reference here. It's important. So I picked this site, and this is one that is actually being considered for solar development. Clearly there's an industrial turbine here. So I know that there's an electrical grid network, and I have an open piece of land. So I have access, electricity corridor, and land. Perfect, away we go. So what I'm going to do now is take legal compliance and put that in place. And with that legal compliance, and assuming I have a participating landowner, I'm going to start marking out areas where I don't want solar panels to go. Now, this can be prescriptive. So if a zoning ordinance has a particular setback distance already built into it, then I can follow those setback distances as a developer. I can challenge them, but that still gives me the place where I want to start. So I might pick a couple of things here, right? And again, this was not exhaustive. I did this in about 15 minutes in a standard development software package. And I'm going to show you what 1 megawatt of solar looks like. So I've outlined a few things here. Let me back up one so you can see what I'm targeting here. I'm targeting 1 wind turbine, 1 cluster of willow trees that's on the left-hand side, and 2 ponds, okay? And when I put those in, I can put back particular setbacks around them. So I can put in a height of various trees, I can put in a height of a turbine, and I can have them all cast shade, and I can give different buffer boundaries around every single keep out that I have. So for a wind turbine, I might have a 300-foot buffer around it. I don't know what that number would be. 300 is pretty high, but whatever number it is, I can put it into any keep out zone. Once I have my keep out zones and I have where the shade is going to be cast by a wind turbine and a cluster of trees, I can lay out solar panels. Now, this is done very specifically. So I have very specific racking requirements, very specific solar panel requirements, and it might look something like this. So what you'll notice here is that the rows of solar panels are aligned north and south. And the reason that this is because pretty much any developer now is going to be using single axis trackers. So these have a single bar, think of it this way, running through the center, and the panels track from east to west following the sun. There's a bunch of reasons why we're moving to this. They are more efficient, they're more cost effective, they're easier to maintain. And by that, I mean the site underneath it. So if you need to mow, for instance, fixed racking is a really hard thing to deal with. Having them be able to move up and tabletop up over your head is pretty easy now. So then I run it through a shade analysis software and energy modeling package. So this tells me at the individual panel level how much electricity they are going to produce throughout the year. And then I can either include or exclude individual modules. Now, we'll come back to this in just a minute. I'll show you in about 2 slides the way that this might work as well. But what you see here is I have forced the system to give me a 1 megawatt system as a default layout. That's it. And in this case, I end up with just over 2,000 modules, so 2,200 modules. This is 1 megawatt of AC, so that's after all the electrical conversions, which is 1.25 megawatts on the DC side, so just adding up all the solar panels. I have done what pretty much every contractor would do, which is not use concrete. So these are just one of two types, either pile-driven posts or screw auger anchors that just thread into the ground and then you fix your racking to them. And both of those are important because at startup, it lowers the cost, it lowers the time, but also in decommissioning, I don't have to worry about concrete anymore. So this is a very easy system to decommission later on. You'll notice that all the solar panels, they don't violate any of my buffers. And I have only a few panels here that are being shaded by the turbine significantly. So you see some that are red and orange. Those are solar panels that probably are underperforming. So as a developer, I might consider what does the landowner want? What are my adjacent landowners interested in? And what's the ease of maintaining a solar farm that looks something like this? Now, this is where landscape architecture is also really important, okay? And system-wide landscape. So you can fit solar panels into a wide variety of different landscapes. And it depends on what a town is interested in. And this is where communities can have some really important impacts here. So I'll come back to that in just a second. How much land are we talking about here? So I'll give you one caveat, and that caveat is I've used state-of-the-art equipment. So I've chosen the best of the best modules and racking to show you what is possible right now. And if I draw a yellow border around this, you'll see that this is just about 4 acres of land. So for every megawatt of solar electricity, you need 4 is really aggressive, okay? Right now, somewhere between 5 and 7 acres is much more common. And that includes not just the solar panels, but buffer zones and all the remaining electrical equipment. So we can take the number that Chris was talking about previously, this these gigawatt values that are part of the CLCPA, right? 6 gigawatts of solar electricity, and or 6,000 megawatts. And if you know how many acres we're talking about, 5 to 7 acres, that tells us how much land we would need in order to hit this kind of a goal. Now that just gives us some value to work on. Now, getting back to the landscape side of things, there are a bunch of ways to look at this. So this is the exact same site, but what I forced it to do is to fall into straight lines. So some people like straight lines because they're easier to maintain. It's much easier to install. Some towns or some landowners might not be interested in that because it now forms very hard lines on the landscape. So you get a more picket fence feel to it. One of the things that you'll notice here is that there are very specific sizes. So one of the more common things you'll start to see more as projects get larger and larger is the row length is fixed. So I can only get row lengths in separate segments. In this case, it's 32 panels on one segment. If I can't fit a full 32 panels, I don't even bother trying to put a segment in there. So in this case, I either have 1 or 2 sections, 1 or 2 tabletops linked together. And if I can't fit 2, I only get 1. So if I go back up, this is the exact same system size, exact same number of modules as this, but you get 2 very different landscape feels about it. And the only reason I want to point this out is planning dictates this softer edge versus this harder edge. And it doesn't matter as a developer which of those 2 someone would select, but from a community that might have a lot of impact. Both can be done very easily, and both are well within all bounds of buffer zones. So what do we get out of this? For that one particular system, we would get 1.67 gigawatt hours of electricity. And that only means something if you know what gigawatt hours means. So it's about 250 typical homes in upstate New York. That's about how much electricity that 4 acres worth of solar panels would buy us. You'll notice that from a production standpoint, We produce a lot more in the summer than we do in the winter, although this is producing electricity in the winter. And so one of the questions I get, because I work in agricultural landscapes all the time, is we don't want to put something up that's not working in the winter on farmland, which is interesting to me when you think of plants that would normally be occupying agricultural zones. They only operate in the summer months and getting into maybe a little bit in the late spring and maybe a little bit into the fall. But there is no operation of that or no conversion of that energy source in the winter. So I see this as a real gain potentially if that is our actual interest, is capturing energy year round from the sun. So once we understand how a developer might pick a site and start working with landowners in the law, the next parts that we're interested in are, the physical infrastructure there. Is it safe? How long do they last? And what happens at the end of the life? Well, there are two ways of taking the safety question. And I get both all the time. I'm an electrical inspector for solar PV systems. So from an electrical inspection side, when I do inspections, I'm looking at electrical safety. Okay, so every single system gets inspected really in detail. And from an electrical standpoint, I'm looking for sealed surfaces, bonded and grounding things, fences around all live parts, and properly guarding of all high voltage DC and AC systems. So we're talking 1500 volts DC is pretty common for these systems. And then on the high side of the transformer, as high up as the substation can go. So, up over, 15,000 volts, 35,000 volts are pretty common on the AC side. So high voltage, they're always on. You have to be careful, but they are properly fenced and guarded, and they're required to by law. Now, on the materials side of things, because a lot of these are going in greenfield sites, people are concerned about what the material impacts are. So it's important to keep in mind that the vast majority of panels that are out there, probably like 94 or 95% are silicone based. And of that, the vast majority of that is silicone. A little bit of phosphorus and boron is mixed into there. But these panels are fully sealed, so they don't interact with the air, they don't interact with the water. And so there have been a lot of big studies done. And in each of these studies, it's pretty conclusive that there are very, very few concerns with damage that causes leaching into a soil of any of these kinds of materials. Now, some solar panels, they're less common. They'll carry things like cadmium. There are gallium arsenide panels as well. All of that sounds kind of scary, but none of that is, they're all in a solid fixed matrix. And so they're not water soluble. They don't volatilize under ambient conditions or even hot conditions. And so it's really unlikely that you'll get any major kinds of concerns. Where it does release is during a fire. And a couple of things that are important there. Once these systems are in operation, if a fire occurs, it's unlikely that they sweep the entire array. It has happened, so I'm not going to say it does not happen, but it's relatively rare to find that. So again, how big of a concern is this? Well, if all the electrical safety parts are being followed, fires are pretty unlikely to happen. And that has to do with the technologies of the modules. The other issue that people are concerned about is hail. So if we break open the glass, will this lead to leaching from hail? So this is actually a really fun test I've watched happen. They take a 1-inch ice ball and they put it into a cannon and fire it at 52 miles per hour at the glass. And every single solar panel that's out there has to pass the test. And so again, it's one of these things where, and why 52 miles per hour? That's terminal velocity of a 1-inch hail under standard windstorm conditions. But so anyway, it's the materials tend to be relatively benign. Now, where this does become a concern is at end of life, which I'll talk about here in just a moment. So toward the end of life, the question is, how long do they last? So a typical lifespan of these systems is 25 to 30 years. And solar panels, they're not like batteries that store things chemically. So they're a fixed matrix all the time, but they do degrade over time because of UV. So they degrade about 0.5% per year. So after 20 years, solar PV modules are typically warranted to be putting out 90% of their initial electricity that they were installed at. So what does that really mean? There are some good options for repowering power plants. So if you have a solar power plant that's 20 to 25 years old, it's quite possible that a lot of those materials can be reused and just repower the electronic balance of system parts. Now, if a project wants to come out, that's fine. Again, because I would highly recommend from a community planning perspective, just mandate no concrete. And if you have pile-driven posts or screw auger anchors, decommissioning is pretty straightforward. And the cost is usually bonded ahead of time. Who holds that money is something for a town to really think a little bit about. And a standard recommendation right now is about $50,000 per megawatt. So where I showed you this, 4 to 5, 6 acres worth of solar, $50,000 for each one of those blocks is recommended for a typical decommissioning value. So let's explode solar here for a minute and let's look to the future. If the CLCPA goals are hit, we have a tremendous amount of solar going on the landscape. Let's fast forward 25 years and we have a tremendous amount of waste, electrical and mechanical system waste. And so the International Renewable Energy Agency did a pretty interesting kind of study to see what end-of-life materials are going to be. And so without getting too far into it, it's pretty straightforward to see this as a nonlinear growth in waste. And what we do with that is going to be really important. So solar panels right now are listed as toxic components and as toxic waste because they do have, I'll say trace amounts, relatively small amounts of, boron or phosphorus and boron. It's important to understand how to treat that. So California actually just passed this not too long ago. And what they are is the first nation to take solar panels off of a toxic waste list and put them onto a universal waste stream. And because California is quite aggressive in what they've done, they're following a lot of European models here, which is looking for much higher levels of reclamation. So being able to reclaim the vast majority of the waste stream, you have a tremendous amount of aluminum, steel, silicon, and copper. And being able to recapture that in a useful way is really important here. So I think California set the stage and it looks like Massachusetts is going to follow this from what I have been able to see. And I expect New York is going to be pretty similar in the way that we'll begin handling waste of large solar projects. It has to go hand in hand with the installation and development side. And so what are we seeing elsewhere? If we think of where solar was at least a few years ago, Spain and Germany were the leaders. And both relatively small nations, but had a tremendous amount of solar. And where they are right now is recovery rates are exceeding 80% by law. And in some cases, they're exceeding 90% by some particular companies. And by recovery rate, I mean what they're actually being able to recycle. So 80% is the minimum, 90% in some area, far exceeds recycling value of pretty much any common appliance we have in our house. So if I were to look at my refrigerator or freezer or washer and dryer set or dishwasher, I can't recycle any of those nearly to this level. And so solar panels have what I think is a pretty strong future in recycling. I can't predict a recycling market, but what seems to happen is because there are good resources in solar panels and there will be so much of it on the landscape, I think it leads to a market that could be pretty strong. So at least in other parts of the world, that is certainly the case. So again, we only had a few minutes here, but I wanted to at least touch on what actually goes into a development side of things, how a company does it, and at least some things to start thinking deeper about on whether or not they are safe. So thank you, and I appreciate it, and I'll pass it on either to Chris or Christy.
Thank you so much, Phil. I think that will generate a lot of questions as we move into the QA a little bit later this evening. We do, I think, do we still have Chris Carrick back? I think he'd like to pick up where he left off and finish up, if you don't mind us jumping around a little bit. So we'll turn it back over to you, Chris. Thank you so much.
Thank you, and I apologize to everybody about that technical glitch. I knew I was going to jinx myself when I said the sun was out, so that's the way it goes. I think I left off here. I was talking about the CLCPA, and I was about to say that NYSERDA put this information out last week in a tweet that I noticed, and I think it's just instructive to show, well, we've got the 70% target by 2030. How are we doing? And so this bar graph shows that we're at about 27% currently. And what is already contracted or under development would represent another 23%. So that's 50%, leaving about 20% left to go. And that's, not an insignificant amount. We're still going to see a lot of new projects come into development. And it'll remain to be seen how that breaks down. Will it break down similar to this pie chart in terms of types of technologies, or will it alter? What's under development or under contract, you can see is more than half offshore wind. So the state has been very active in promoting offshore wind, which I think is terrific because it will serve the downstate load, which is quite significant, and help to offset the closure of Indian Point. But this light yellow color here, you can see 28% large scale solar. That's the utility scale solar that's gotten so much attention. The darker shade of yellow or gold, 7% is distributed solar, and I'll talk about what those terms actually mean in a moment. But I just want to make the point, Sherry sort of alluded to this, that making our electric system cleaner is really the key to unlocking transportation and building heating and cooling. So switching to electric vehicles, air source heat pumps, ground source heat pumps, all powered by renewable energy. That combination of technologies and approaches is sometimes called beneficial electrification, but really is going to be the key to meeting our carbon reduction goals overall. And so as our system gets cleaner, it makes all the other things that we need to do that much easier to achieve. I will say, just by the by, that our upstate grid already is the cleanest across the country. If you look at our megawatt hours, pounds of carbon per megawatt hour, we are the lowest because of our nuclear and hydro facilities and our renewable energy facilities. So where is the solar market today? This information is from NYSERDA, current as of the end of the first quarter of this year. So you can see we're closing in on 3 gigawatts, 3,000 megawatts, with almost 150,000 projects installed across the state. So we're about halfway towards that 6,000 megawatt goal that was established in the CLCPA. Looking at central New York and drilling down even into Madison County. In central New York, we have about 78 megawatts with a little over 2,500 projects completed. In the pipeline, though, you can see quite a lot of activity under development. So almost 360 megawatts of projects under development, representing 129 projects. And if you look at the average project size, just using those figures, it really does reflect a transition from the rooftop solar that we were working on during our Solarize Madison campaign towards the community solar kinds of projects that we're seeing pop up across the region and across upstate. Same thing holds for Madison County, 16 megawatts installed right now, an average project size of about 46 kilowatts, but looking at the pipeline, that average project size goes over 2,000 kilowatts. So again, a shift towards the community solar end of the spectrum. I noticed someone put in the chat, how does community solar work? How does the community or residents benefit? The reason why the state moved towards enabling community solar is because we know that only about a quarter to a third of residents in an average community can actually install rooftop solar at home. That's because a good portion of us are renters. Perhaps our roof is not in good condition. Our roof may be shaded, it may face the wrong orientation, or we may not have the funds up front to pay to finance a rooftop residential solar installation. So to unlock the power and the potential of solar for everybody and make that equitable transition that Sherry was talking about, community solar really does make solar available to every New Yorker. The way it works is a developer, like Phil was talking about, shown here as a sponsor, builds the solar array. It's connected to the grid. That goes into the grid. The utility takes that power and then supplies bill credits to those who subscribe to the community solar project, or in some cases, buy a share of the community solar project. The subscription model is by far the most common and prevalent form of community solar right now. But really, especially under the advent of consolidated billing, where subscribers only have the one utility bill from National Grid, say, it really does make it quite easy, and the savings appear automatically on your bill and appear immediately. So what are we seeing in terms of community solar? Looking at what's in the queue for the utilities, and this is all public information, we see across National Grid 77 projects, community solar projects installed, 7 in central New York. But when you look at what's actually in development, you can see almost 800 community solar projects in development. And again, the average project size is increasing. 133 community solar projects in development within central New York alone. So we were a little bit slow out of the gate in our 5-county region, but we're catching up quickly. And then NYSEG, a little bit less in development, a little bit more actually completed, but the picture is much the same, a trend towards larger projects. Now looking at large scale, utility scale projects. Since 2017, NYSERDA has invested $5 billion or so procuring large scale renewable energy projects through a competitive process. So developers actually bid to NYSERDA to say how much subsidy they need to make their project financeable. And NYSERDA awards funds to those that require the least amount of public resource. So it really is a wise stewardship of our public ratepayer dollars. So a number of projects across the state, you can see, I won't go through the details here, you can look at this later, but quite a lot of activity on the utility scale side. Until recently, these projects were managed through the state's Article 10 process. You can see a map here showing active solar projects as of last spring. Quite a lot of projects in the western part of the state and then all along the ring of the Adirondack Park. Typically, these projects need access to transmission lines, and so that's where these projects are developed, as opposed to the community solar projects, which connect to the distribution side of the grid, the 3-phase power lines that we're used to seeing along our roadways. Now, this map just shows projects in the ISO, or Independent System Operator queue, and shows them oriented by size. Again, you can see heavy concentration in the west and then along the rim of the Adirondack Park, some up in St. Lawrence County. Again, this breaks down projects by size. You can see quite a number of projects at the larger end of the scale, but most are within that 20 megawatt range. And under the new Article 94C process, which was established by the Accelerated Renewable Energy and Community Benefit Act, these are projects that, if they are 20 megawatts or larger, the developer can elect to go through a state-run permitting process through the new Office of Renewable Energy Siting within the Department of State. So this has caused a bit of controversy among some local elected officials because it does impinge to some degree on home rule authority, although there are allowances made for, the whole intent is to establish a balancing act between home rule authority and the goals of the CLCPA. And we can talk about that more later. Phil covered a lot of the basics of Solar 101, so I don't really need to get into this very much. Again, you'll have these slides for later reference. I did want to just talk a little bit about the development cycle, not to go in through every step of this, but it is a long process. I want folks to feel assured that these projects don't pop up overnight. And as I said, I've been working with a number of municipalities to develop solar projects on their facilities or property, and I can testify from firsthand experience. These projects are many years in the making. You can see here 18 to 24 months is typical, if not longer, and when you go through all the steps. But the first step is securing access to the property, and then there's a very lengthy utility review process. NYSERDA, of course, is involved heavily, but then lots of engineering and environmental permitting goes into this, as well as pilot agreements or with the County Industrial Development Authority or the local municipality. So quite a lot of steps need to be taken to develop these projects. When looking at, how to zone for these, Phil touched on this a little bit, but I do want to just say that, developers typically are not looking to clear a lot of land. They're looking for open, flat, dry land. They are looking to use as little concrete as possible, as Phil mentioned. And these projects can exist with agriculture, coexist through the use of pollinator-friendly plantings, the use of sheep. Grazing is becoming more prevalent, and the impacts on wildlife are typically fairly low. Nesting birds can coexist if these are planned properly. Deer can come in and out of the fences typically, and they are pretty good neighbors. They're quiet, they don't produce fumes, lighting, glare is not an issue. They don't increase traffic, they don't demand services, police, fire, school services from municipalities. So all in all, they're pretty benign, I would say, from my perspective as a planner. And the ways to mitigate these impacts are the kinds of things that municipalities have always done in terms of zoning. The primary tool is siting. Where should these projects be located? How high should they be? What should the setbacks be, either from roadways or other property lines or other residences? What kind of screening should be involved? Safety was covered very well by Phil. What are all the required studies? Quite a few. And then decommissioning and site restoration, as Phil talked about. NYSERDA does have quite a lot of technical assistance available. I want to mention the Solar Guidebook has been out for a number of years. That includes a model law. Our agency has developed a model law as well. And as I said, we've worked with a number of communities, most recently the town of Pompey, to develop an overlay district approach to their zoning law. And then NYSERDA has recently published a guidebook for battery energy storage systems. And they've been hosting a series of webinars recently. Again, those are on NYSERDA's YouTube page. That is becoming more prevalent. And so that is an increasing area of interest for municipalities as well. And then just to conclude, I want to just sort of give a little bit of a big picture, picking up on some of the points Sherry made. Again, going back to our regional sustainability plan, we looked at the opportunities to develop the region's solar resources. But when you look at, our region, we have quite a lot of transmission infrastructure, particularly in the north and around the metropolitan region, and then running through Madison County down into Cortland County here. So these are opportunities for the utility scale projects. But we are an energy producing region because of, reflected in the transmission infrastructure that we have. We produce 4 times as much energy as we consume locally, but our energy generating power plants are aging, including the nuclear power plants. So it is wise to plan for the future, not only for the carbon emission goals that we have, but for the resiliency of our infrastructure. And we can talk about that during the Q&A. These are some interesting facts that I pulled out about our region, looking at the number of passenger vehicles, buses, single family homes, multifamily commercial buildings, et cetera. just to show sort of how far we've come, but also how far we need to go. So you look at how many electric vehicles are registered in central New York, about 0.5%. Alternative fuel buses, just a few really. How many homes have been weatherized? Fewer than 10% of our homes have been weatherized. How many residential solar projects do we have? Less than 1% of all the residential homes have solar PV. So, we have a lot of work to do. And again, making that transition to a clean energy, clean electricity system is going to help us achieve all the goals that we need to. Looking at our regional sustainability plan, we looked at where were we back in 2016. We had 22 megawatts. And what could we achieve feasibly? With a 33% compound annual growth rate, by 2030, we could feasibly achieve 20% of our installed generating capacity with solar. That is, I think, easily technically feasible at this point. In fact, we can probably go double beyond 20%. And community solar, utility scale solar is the trend, and it is what is going to be necessary to get us there. And then finally, again, picking up on Sherry's point, I pulled out some statistics in terms of what is our responsibility and what is our opportunity here in central New York. So our greenhouse gas emissions are just under 10 million metric tons. Out of less than 5% of New York's total, less than 0.2% of the United States total, and just a small fraction of the world total of greenhouse gas emissions. It would be easy to say, what can we do here in central New York? What should we do? What is our responsibility? And maybe say, well, it's really not much. I think that's the wrong way to look at it. Not only do we have a moral obligation considering the historical emissions that we put into the atmosphere, but also our per capita emissions are double, triple, or even higher those of the per capita emissions in the developing world. So I would argue we have a moral obligation, but we also have an opportunity here to make this clean energy transition. Some of you may have seen last week, I think it was, a leaked early version draft of the new IPCC report came out, warning that the worst is yet to come. This was by far the most dire language contained in any IPCC report. And notably, it talked about tipping points. Previous versions of the report have been criticized for not discussing these tipping points, like melting permafrost, like the loss of the Greenland ice sheet. Tipping point means we've set in motion a process which cannot be reversed. And I would echo Sherry's point. It's not too late, but time is running out. The matter is urgent. And so hard choices will need to be made between things like visual impact. Some people don't mind the sight of a solar farm. Some people think they're ugly. But that has to be weighed against what I would say is a civilizational crisis. And so that's not to say that we can't plan well, we shouldn't plan well, we shouldn't cite these projects in the appropriate places. But I'm confident that we can balance those interests. I am a planner, that's what we do. Try to balance those public interests and those community interests. And I think by working together, we can achieve that. And I applaud, again, the hosts of this webinar for putting on this educational forum so that we can discuss these important issues together. So thank you.
Thank you so much, Chris. We're glad we got you back for the second half of your presentation. And I know we're running a little long on our time here, but there's been so much great information. I've been hesitant to shut down our speakers before they're ready and before they finish their presentation. So if you'll bear with us, we have one more speaker this evening, and I would like to now introduce Christy Anderson. She's a professor emeritus of political science at the Maxwell School of Citizenship and Public Affairs at Syracuse University. You probably know her best as a town of Cazenovia counselor. She's served in that role for many years now. So Christy, thanks so much for being with us tonight. Oh, and Christy, you're on mute.
Okay. Am I okay now? Yes, okay, thanks, Jen. I think I can be fairly quick, in part because the previous speakers have really done a good job of providing a lot of information and setting the stage for what I'm going to talk about, which is really a fairly quick story about what the town of Cazenovia has done in the past few years to encourage and to regulate solar energy systems. And I would say that if you're interested in looking at the regulations, they're all online. You can go to the town of Cazenovia website, go into the town codes, and you can see what exists now in terms of siting and so forth and so on. So we became conscious really of the need to move toward renewable energy over the last 10 years. Like most people in most towns, I suspect, we adopted an initial law regarding solar energy systems in, I think about 5 or 6 years ago, recognizing the importance of these. This law mostly had to do with home solar systems. So it permitted building integrated and rooftop solar systems everywhere in town on all zoning districts, subject, of course, to New York State safety regulations and so forth. We did adopt the New York's unified solar permitting, as Chris, I think, mentioned. We recently voted to amend those laws a little bit by voting to allow ground-mounted systems in more areas of the town. So we're trying to make it reasonably easy for people to install home solar systems. And we realize at the same time that, as Chris said, only a fraction of people will be able to afford to or have the capacity to do that. So more importantly for this discussion, we included in the 2016 solar law provisions for what we referred to as solar farms. And the definition in our laws are a solar energy system used to convert solar energy to electricity with the primary purpose of supplying electricity to a utility grid for wholesale or retail sales of electricity. So community solar is what we've been talking about. We had some people come to the town board expressing interest in this. Some people had talked about a property a little bit west of New Woodstock, north of Route 80, another property, I think on Reservoir Road, also in the southern part of the town. And neither of these didn't culminate in any concrete proposals. But as many of you know, over the last year, our planning board and zoning board of appeals have been working with developers of 2 different projects, really. One has actually had its approval. This is a 5-megawatt solar farm on Barrett Road, south of the hamlet of New Woodstock. We were working with a Massachusetts clean energy company that has an office in Syracuse, and that site plan for that solar installation has now been approved. This will be on leased land, about 25 acres of a 75, I think, acre site. And the installation itself will cover about 15 acres and be, as we've heard from people, surrounded by a security fence and so forth. And that will be tied into National Grid and generate about 9,400 megawatts per year, enough energy for an estimated 770 homes. And as Chris described, this is going to be, I think, a subscription. So you'll get the deduction, so to speak, on your bill if you sign up to subscribe for this. And I don't know, I really know very little about how that will work. But the property owners will purchase subscriptions and they'll receive credits on their bill. This project is predicted to provide about 6,700 metric tons of greenhouse gas savings per year. I don't really understand that completely, but I'm saying that for the people who do understand it better than I do, like Sherry and Chris and Phil, everybody but me, in fact. The project, it seemed to me, and the pandemic allowed me to attend pretty much all the planning board meetings and the zoning board of appeal meetings that were dealing with this project. And it seemed to me that our current law was reasonably pretty much able to deal with the concerns that were raised about view sheds, preservation of agricultural soils, and other environmental concerns, which usually come up, as we've talked about in these projects. It also seemed to me that the particular energy company was quite cooperative. The process was long and detailed, but pretty collaborative, I would say. And some of you who may have followed this might be able to support my my statement there. So for example, they will plant hundreds of trees and shrubs, native species, as well as pollinator-friendly plants among the solar panels. So there was a lot of discussion about protecting migratory bird paths, protecting animal habitats, and so forth. There has been also discussion, which many of you may be familiar with, of a 10 megawatt solar farm in kind of 2 5 megawatt pieces, I think, on property that's bounded by East Road and Balina Road. And that is in a more residential area and has produced more concerns. That project is on hold right now. And I'd say these projects together, and particularly the questions that have been raised about the one on the near Balina and East Road, and the possibility of additional proposals coming around, encouraged the town board to enact, which we did last week, 2 weeks ago, a 12-month moratorium to review and revise our current solar law. So the purpose of the moratorium is simply to do that. It's to make sure that we have the best regulations we can to both encourage community solar systems, but make sure they are in the right places. And let me talk a little bit more about right places. And this is touches on things that Phil talked about and things that Chris talked about as well. So there's a committee that is already working on this, and we're actually into revising the law. This is myself and Jimmy Golub, who are on the town board, Ann Ferguson and Bob Riddler, who are on the planning board, Roger Cook, our code enforcement officer, and John Lange, who's our town attorney. And I would just say one note about John. He has been our attorney for 16 years. He lives in Cazenovia, and he's a super expert in the area of municipal law. I can't overstate how important it's been to have someone so knowledgeable about municipal law working with us. And I thought about this weekend. Some of you may have read an article in the Post Standard about the town of Clay, I believe, who had worked with 2 different developers, they were building 2 big solar farms, which I think are completed now. And they had the towns failed to negotiate a pilot agreement that is payment in lieu of taxes, or what's called a host community benefit package. Now it's too late, apparently, for this to be done. And I thought this would not happen in Cazenovia. We will definitely include those requirements in our law and do. So regarding our work on the solar law, I would say that so this law is, if you go online and look at it, it's really comprehensive. Again, it goes everything from where you put things in your yard, if you're doing ground mounted solar system, or how do you make sure that rooftop systems are safe, and to how these bigger solar farms should be sited and so forth. So some of the things we're dealing with right now in terms of making the law better are dealing with storage batteries, something which we didn't talk about in the first iteration of this. attempting to prevent so-called oversaturation of solar farms in particular areas of the town. We're putting in more details about requirements for non-invasive native ground covers to provide habitats for insects and birds and animals, using native vegetation, requiring specific information about noise to be generated. I know Chris said, and Phil, I think too, that they are not noisy, but again, need information about this. A lot of detail about the insurance that the company must have. And this is something that Chris mentioned as well, requirements for a very detailed decommissioning plan, including detailed requirements for the restoration of agricultural soils and bonding, as was mentioned. There's also requirements for road repairs if those are necessary after the construction of the solar farm. And one of the things I like about what we're creating is that the law will contain not only all these regulations, but kind of a translation of the legalese into a very detailed and very specific series of guidelines for solar installations. So not just what you can't do, but here's what you should do. And if any of you have worked with the town of Cazenovia on any land disturbances on the lake waterfront, you know that we developed several years ago guidelines for lakeside development in terms of, using natural vegetation and dealing with slopes and and so on and so forth. Very detailed. And so these guidelines for solar farms is similar to that in the sense of it's a proactive, here's what we want it to look like, here's what we want you to do. And it's, I think that'll be useful for people. So the final thing I would talk about is, again, being proactive about this rather than just reactive. Somebody, I can't remember which of the other speakers said this, but that's very much what we want to do. And very fortunately, we were approached by Jen and people in CPF who had been looking at work of Scenic Hudson, a land trust in the Hudson Valley that has been working specifically on siting solar installations, in part through the use of geographic information systems, GIS, sort of some of the stuff Phil showed us in his slides, which can generate lots of layers and points. So you can have anything in there, as I understand it, from historic sites to soil characteristics to wetlands, viewsheds, riparian areas, so on and so forth. So you can kind of see at various levels what you're getting into in a particular area if you were to plan a solar installation. The idea is to allow us to develop knowledge of what would be good locations in addition to what would not be good locations for various reasons and various things that need to be protected. So we hope will allow us to think proactively about solar installations rather than simply waiting for a developer and a farmer to get together and come to us and say, hey, we want to build a solar installation right here. That will still happen, I'm sure, but this, I think, gives us some advantages in thinking about this. CPF, as I understand it, has employed an intern for the summer. Jen can tell us more about this, I think. And from Colgate through Colgate Institute, and will be able to, or Upstate Institute rather, and that person will be able to help us engage in this work, I think. So I'm very much looking forward to working with her. So that's all I have to say. I'll answer any questions that people might have.
Wonderful. Thank you very much, Christy. I know we are at the 90-minute mark.
Yeah.
There's been so much great information. And I think we will open it up for some questions, but we will keep it brief for tonight. but know that this is not the last opportunity to have these discussions and raise some of these questions. So thank you to all 4 of our panelists for being here with us tonight. I do want to, just as we get into the questions phase of things a little bit, just offer a reminder that this evening's session is really about building a broad knowledge base about commercial solar or siting commercial solar in our area. Christy spoke a little bit about a couple of specific projects that have come up on the town's radar, but we'd like to keep tonight's questions focused or keep questions tonight a little bit more broadly themed for this evening. So if you would like to ask a question, we'll start with some of the questions that came through the chat. If you would like to ask a question, if you can either enter it in the chat or use the hand raise function in Zoom, and then we can call on you to take your question. So I'll start with, maybe we'll start with a couple of broader questions and then zoom in a little bit. We had a question from Stephen Evans, who wrote, The Economist has published data suggesting that about 2% of the entire US landmass will need to have solar in order to reach a zero emission status by 2050. Is this number reasonable? And I'm going to pair that with another question about scope and scale a little bit. We had another question that came in. Can a solar project provide enough electricity for Cazenovia? So looking at this both from the US scale as well as what we can do here in our community. And do any of our panelists want to field that one? Maybe Chris or Sherry?
Chris, yeah.
So the Economist number is only solar, but as a reference, I think the amount of land mass that is urbanized in the United States is 2%. So it's about equivalent to the amount that is currently urban. Most of our land mass is in prairie and pasture and forest and otherwise. So it's really not a huge area, but that's just so that is assuming that you're gonna get to zero by 2050 only using solar. They didn't put in all the dams, all the hydro, all the geothermal, all the other renewables into that mix. So if that number is probably reduced more than half or even more if you put the whole mix in there.
I would agree with that. I mean, again, part of the rationale behind our project was to direct development away from greenfield sites and farmland. There are various estimates about how much land would actually be required to make a clean energy transition for New York or for the United States or for the world. I think it's a red herring to say that we're going to cover over all of the land in Cazenovia or New York or anywhere with solar panels. And we don't need to reach the transition. 1% of our land is in golf courses. Is that too much? You look at Richard Perez's work from University of Albany. He's done some really interesting research on what is the potential of siting solar along utility rights of way and highway rights of way and underutilized land. And the potential is enormous. And the other point to make is that there's an inherent limit on what can be developed and where, and that's the utility system that we have. So there are utility hosting capacity maps. This is National Grid's map. Anyone can go on this site at any time. And this shows you actually what is the hosting capacity for every feeder and every substation. So just click on the substation and you can see what the capacity is. This is a speed limit on the highway of solar development, if you will. What we see is the darker red colored lines show not much capacity for solar. The blue and green lines show there's more capacity. So when a municipality looks to develop their solar zoning law and do the kind of exercise that the intern will do this summer, not only do you want to layer your prime soils and other community features, natural features, you want to look at this utility system. And I like to show this just to sort of allay concerns that we're going to be covering over the whole town with solar.
Great. Shifting gears a little bit, we've got a couple more questions from the chat. A couple of these are related to the benefits of solar for the community. So broadly, how will the benefits of solar be shared with the community? And how are the benefits related to reduced energy costs work, particularly in towns where residents use multiple energy providers, or benefits for towns that have, or municipalities that have large populations, for example, Amish populations that are not connected to the grid? And how do you equitably share the benefits of solar with all of the community members?
So with community solar, particularly the subscription model, the average bill discount that a subscriber will see is about 10%. There's typically no sign-up fee, no penalty for canceling your subscription, as long as you give some notice to the project owner. So that's one immediate benefit. Another benefit are the tax or pilot agreements or host benefit agreements that developers will enter into. We're seeing pilot agreements in our area of about $3,500 to $5,000 per megawatt. Now, those pilot payments are split between the town, the county, and the school district. So the town will get a fraction of that. Again, these projects do not demand municipal services, don't generate traffic or wear and tear on the roads. So they're pretty much a net benefit from that perspective. And then for the larger utility scale projects, the Accelerated Renewable Energy Community Benefit Act that I mentioned has a requirement for a host community benefit agreement to be entered into between the developer and the host municipality, including a bill discount for members of the community, which by my calculation would average about $50 per household. So there are a number of benefits that accrue to not only the municipalities, but the local residents.
Another question from the chat. Can a municipality create their own regulations regarding setbacks and expect them to be followed versus state guidelines? So I presume this is, refers to the larger scale 20 megawatt and up projects, although the question didn't contain that info.
I mean, I can respond a little bit to that, and we've been concerned about that, the New York siting provision for the big ones. In fact, we've talked about, I don't think we will probably do it, of seeing if some towns, Chris can probably correct me if I'm wrong about this, have tried to or want to ban installations that are over 20 megawatts because of that. New York will come in there and do all the siting and destroy home rule, or so they say, or so they see it as that. So couldn't we just say we aren't going to have any installations more than 20 megawatts in our municipality? I don't know the answer to that, but we've at least talked about that. Other than that, below that, yes, we have all kinds of powers to regulate the, what's planted and how high the fences are and how the things are protected and so forth and so on.
Yeah, I would just add that the draft regulations that the Office of Renewable Energy Siting have adopted, so they're not draft anymore, has a 100-foot setback provision.
Yeah.
So that is sort of the standard that we're seeing a lot of municipalities sort of gravitate to, recognizing that if it comes down to it, that Juarez, may override a setback that was 200 feet, let's say.
Yeah.
So I see two more questions in the chat. We'll address them very quickly, and then I think we're going to cut off the questions for tonight and continue this on another occasion. The federal tax credit is changing soon. How will this impact new solar projects if all the towns are starting one-year moratoriums that will push these projects out further than 1 or 2 years? And there was a response to that in the chat, but wanted to make sure that everyone had seen that. Chris, do you want to follow up on your chat response there?
Yeah. I mean, this is a question that comes up all the time when towns are considering, should a moratorium be 6 months or a year? In my view, you know, a moratorium of a year will certainly hurt projects. You know, assuming that the federal tax credit is not extended. These projects live and die by the tax credits. There's a very complicated financing structure of equity and debt that goes into these projects. And anything that delays these projects or puts in jeopardy that tax credit is a significant risk to the project.
And Christy, it looked like you maybe had a comment that you wanted to add there. Oh, Christy, you're on mute.
Yes, I understand that perspective. I don't, as I said before, I think we are not planning to take 12 months to get this law in shape. In fact, we had a meeting yesterday where I thought, you know, we made a lot of progress toward getting it revised in the way we wanted it to be revised. We're not making huge changes.
And final question from the chat. Do community solar projects typically set aside power for quote unquote public use? Say, could the town require free EV charging stations within a mile, for example, of the project? Phil, do you have any, you know, you've got a lot of experience with project-specific questions and citing. Is this anything that you've seen?
I haven't seen one specific for EV charging stations, but so again, the scale of projects is really important to keep in mind here. So community solar projects typically are done on a meter basis rather than, so as Chris was describing, you have a group of individuals who will opt into this, and then their meter accounts for some portion of the electricity that comes off. And so they're all remote net metered kind of together as a group. So I suppose it's possible to write that in there, although that would typically not be part of a community solar project. But it's one that I haven't seen before, but I don't know if Chris has seen any of the EV charging stations or anything in particular of a set meter or 1 or 2 meters that go to some public use. I have not seen that as part of the community solar model previously, though.
I have not. Under the community solar guidelines, up to 40% of the power can be sold to what's called an anchor customer, like a large college or municipality, for example. You know, as part of the host community benefit agreements, really it's open to negotiation. So we have seen developers, both for community solar and utility solar, provide a number of benefits to the municipality. It can be cash, it can be things like EV charging stations, educational programs can be established. We've seen that. But no, the power is typically fed into the grid, and the electrons go where the electrons are needed as a matter of physics. And then the benefit to the subscriber is really an accounting exercise, where the meter at the project measures how much power goes to the grid, and then the developer allocates the shares, if you will, to the subscribers based on their particular agreements.
Well, I think that is all the time that we have for tonight. We've probably gone a fair bit over what you had originally anticipated, but thank you so much to all of our panelists. I think it was a great summary of information, and I think sets us up for the next in the series of 3 additional panel discussions that we'll be planning for the fall. So what's next? We'll be putting out, we are looking to put out a survey to gather some feedback on this, and also a broader survey to gather some additional feedback from the community members regarding renewable energy generation projects and implementation in our area. And hopefully those will help to shape some of these 3 follow-up sessions that will begin in about September 29th will be the first one. We'll have about 1 a month through the fall. So the first event, September the 29th, Christy spoke about this a little bit in her talk, will be a presentation about CPF and Upstate Institute's work to adapt the Scenic Hudson's How to Solar Now toolkit for Cazenovia. Cassie Ferrante, who's here on the call with us this evening, is an Upstate Institute fellow this summer, and she'll be working on some of those siting tools. And I come back to my favorite soundbite of the night, I think, was Chris. In your presentation, you spoke to the fact that the primary tool is siting, and so hopefully through that work, we can help to build some better input for our community in what we want that to look like here in Cazenovia. The October session, October 13th, will be focused around the industry perspective and economics of commercial solar, primarily at the community scale level, but also looking at larger projects. And then in November, we'll be hosting a session that is focused on farmland conversion to renewable energy generation. We're hoping that those events can be hosted in person. We'll make that determination as we get a little closer to that date. So in closing for tonight, thank you all. Thank you to our co-hosting organizations for working with CPF to help identify the knowledge gaps and build the framework around some of these emerging themes. So Lauren Lyons from CACTA, Jeff Navias and Mary Bartlett from UCAN, and Jack Stevens, Megan Kelly, and Anna Marie Neuland from the Chamber of Commerce. I'd also like to thank our 4 presenters. Thank you so much for offering up your time and your expertise to help build our collective understanding about this complicated and important topic. And most of all, thank you to our audience for being engaged on this topic and for participating constructively in tonight's conversation, and for sticking with us through power outages and absorbing all of this information that our panelists brought to us tonight. And we look forward to seeing you again when we regroup in September. Thank you all, and good night.
Thank you, Jen, for organizing.
Good night, all.
Thanks so much.
Have a good night.